Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. We're going to wrap up our study of solving systems of linear equations by looking at some techniques that are more about just algebra, row manipulations, etc. So first, as a reminder, if we have a system of linear equations where every variable is to the first power, I can rewrite it in this matrix form as ax equals b. But that's not the only thing I want to do. So there are a couple of things we can do. One is the Gauss-Jordan method. You may have covered this, where basically you can multiply any equation through by a constant or divide by it. And then you can add or subtract two equations to create a new equation. And if you do that, these are called row operations, and you can rewrite this matrix form so that if you do this to both the right-hand and left-hand side, you end up instead with the identity matrix instead of A, and then that is equal to whatever the math turns out to be, and that's your list of answers. And that's certainly something to do. It's not something we're going to really pursue in this class, but it's a good technique, and you've probably been doing that when you solve systems by hand. We're going to look at another technique that also is attributed to Gauss, but this is the Gauss-Seidel iterative technique. This is essentially successive substitution for a system of equations. So you're going to start by taking each equation and solving for a different variable. So maybe you solve the first one for variable x1, the second equation for variable x2, the third for variable x3. And what you're going to do is you're going to start by guessing a value of x, and then you're going to take and substitute in those guessed values, and always keep replacing your guess every time with whatever your most recent calculated value was. And you're going to keep doing this until it converges. Now, this isn't going to be guaranteed to converge, which is going to be a problem, but it's advantageous because it also works for nonlinear systems of equations. But we're going to first look at it for these linear systems. So this is the algorithm shown here. Basically all it is you're going to take a series of guesses. You're going to go through and calculate each of these using your formulas, and you're going to look for the relative error limit like we've done before in earlier techniques, and stop once you've gotten close enough. Now, can you guess in advance whether or not this is going to work? Well, it's going to really depend upon what the forms of the equations were. This is going to work best if you are solving for the value of x that had the largest coefficient in your equation. So you can rearrange the system if you need to so that you get it into that form. Now, how quickly it's going to converge will depend on the first guesses, and this is going to guarantee convergence if your CIIs, so your diagonals, okay, are larger than the sum of all the other CIJs for that row. Okay. Now, let's look at this. This is the system of equations we've been doing. And let's just simply rearrange, and I've solved each one for x1, we'll divide by 3, x2 if I divide through by 16, x3, x4, and so I can do that, and I've got that in my Excel over here, and I've already set these up. I put in guesses for 0, and now then I've got my formulas typed in, and those formulas, let me just show you. They are, just exactly what I had typed there. So, right, I just said divide by 3. And if I go through and do this, each time I'm using whatever the values of x were that I've guessed up here. Okay, so you can look and see I'm always using the previous set of values. And if I copy this, since I've used relative references, it'll just keep repeating as I move down. But you'll notice that it's getting out of hand really quickly. Now, possibly it would have worked better if I'd used better guesses. So if I switch to -1, 2, 1.5, and negative 2. That was a negative 2. You know, you think, oh, well, I'm closer, so it should work better. But even with some really pretty close first guesses, it's terrible, right? So let's look and see what happens if I switch the ordering. So this equation, x3 is the one with the largest coefficient. So I solve for x3 from the first equation. This one, all of them are about the same size, so I'll come back to that. This one, it's definitely x1 is the largest. And this one, x2. So I have an x1, an x2, and an x3, so I'll solve this one for x4. Okay? And if I do that, and again, divide this top equation, everything by 47, everything by 10, everything by 56, and everything by 66, then when I come into my Excel, and I can put in those bad guesses again, then I've done the equation for x1. You don't have to do them in any particular order, but I did it so that it was x1, x2, x4. Okay, so I went through and did each of these. And this time, as I go through, it is getting closer, but it's not getting closer very fast, right? It's fairly slow convergence. But it does, if you are patient, it does eventually seem to get there. Okay, but man, is it slow. If I do these better first guesses, it does really improve how quickly it gets there. Okay, so it's successive substitution for a system of equations. It's called the Gauss-Seidel method. So that's one thing. Another is that we can take advantage of the fact that Excel has a built-in iterative solution technique, which is called solver. This is going to work best if you set these up so that all of the equations are of the form something equal to 0. Now, I usually just take right-hand side minus left-hand side, or left-hand side minus right-hand side, simple-minded, set equal to 0. You're going to set up the equations in that way. You're going to enter into Excel first guesses for each of your x's. Then evaluate each function by cell reference. So you want to use these, methods where you're pointing to a cell. And you're going to enter your guesses for x. Now then, you want all of these to be 0. And you want them to be 0 at the same time. I am not going to be happy if one goes to positive 1 million and one goes to negative 1 million. And I say, well, on average, they went to 0. Because no, that's terrible. So I want them all to go to 0 together. So I have two choices. I can do absolute values or squares. Both of those will get me positives. And I'll add up the sum of each of those absolute values or the sums of the squares. Now, once you have that, that's going to be my objective function. So now you're going to open Excel. It's going to be in the Data tab once you've added it in, okay? And you're going to, with Excel, you're going to solve for the objective function, the sum of squares, setting it equal to 0 by changing the cells where you guessed x. And then you're going to say okay or solve or whatever it asks you to do. So let's look at that. And again, I have already set this up, but let's put in our first guesses here. We'll put in naive guesses. And these are my functions, and I've done them all so that it points to cells up here. And you'll see that in this case, they're all negative. But then I created down here this objective function. So this is my objective. My objective is that I want this to go to 0. And right now it's positive 8,000 something, okay? So I've taken each one of these and individually squared them and added them up. You can also do absolute value of each one individually and add them up. That's going to be my objective. So now then, I'm going to go to your Data tab. If you have Solver showing up, then you're ready to go. If not, come to File, Options, Add-ins, and then look and see if you have the Solver add-in. If you don't, find it down in your inactive add-in list. Click on it and then say Go and then say OK. All right, so I've got mine added in. So Solver, I'm going to set cell N14 equal to a value of 0, or I could say a minimum, by changing these cells here. So I can highlight a series of cells to change. And then you may or may not want to add constraints. A common one is that you want all positive answers. I don't in this case, but if this is checked, it means that you want all of your answers to be positive. But you can add other criteria if you want to. We may or may not get to that later in this course. And say solve. And it takes a moment and it comes back and it comes up with the answers. And they are really very close. So this was also very simple-minded. Again, we actually can access this from VBA, but again, the way to do it is to write yourself a macro and then look at that code and borrow it as necessary. So at this point in time, this is going to conclude our series of lessons on solving linear systems of equations. We will be coming back and looking at nonlinear systems of equations in future lessons. Thank you very much for your time.